Hello and welcome back to my Java tutorial series. Right now you can see our finished product for episode 7, which includes a lot of classes. Now I was about to start a new Java project for episode 8, and today we're going to be going over errors and exceptions. So let's just start right up with, of course, our regular package and our regular main class. Now, okay. So while I set this up, let's explain what an error and what is an exception from the Java standpoint. Now, Java, how it handles things, normally everything is an error. Speaking, yeah, basically everything's an error. But then that is subcategorized into exceptions and runtime exceptions and, of course, errors. So what happens is that an exception is an actual Java class, which of course is an object as well. So in fact, it's also an object. So we could do this, throw and throws is a different keyword. So this throws null pointer exception. So basically what it means is that this method can now, the runtime now knows that it can throw a null pointer exception, which is a runtime exception. So let's get into more of the definition. As far as Java goes, you know, there's the error, the exception, and a runtime exception, and they kind of go in a hierarchy from that. An error is anything that the operating system throws at the program that could cause it to terminate, such as out-of-memory error or other things. And then an exception is basically an exception. It's all exceptions, but exception as opposed to runtime exception. A runtime exception is an exception that can be handled programmatically. So that means whenever you get a runtime exception, it is entirely your fault as the programmer that you got that exception. A null pointer exception is a runtime exception. So if we make a public static array of integers, and we declared it, but we didn't initialize it, and we try to do system.out.print line. What the hell is wrong with my spelling? So if we try to print out the int array, which of course each int array is weird, but let's try to print out int array 0. So it would print out a number if we had it, but you'll see we should get a null pointer exception. See, java.lang null pointer exception. Basically, everything from java.lang is auto-imported. I told you about imports in a previous episode. But here, you know, we have a null pointer exception, and it happened at this point. Right here. It tried to print out something that was null. Since this wasn't, it was declared but not initialized, and you're trying to call something that needs to be initialized, you got a runtime exception. So how we would, there are, the basic ways are, well, let's determine how exceptions work. Basically, when an exception or an error or a runtime exception is ever thrown, it originates in the method where the error occurred. So let's just make a different method. We'll just make a public void initialization and init. Yes. We'll just put that in there for right now. So right now, if this were to run, the method in which it occurred would have been initialized, which isn't running. My fault. And of course we have to make this static. So we initialize it. Right now, it happened. The way Eclipse tells you where errors happened is main. Is at the bottom it tells you exactly the scale of things from all the way from the main method all the way down the ladder of occurrence. It goes down to where it actually occurred. So how the exception ladder works is that it happens at the method where it occurs, and if it isn't handled, I'm sorry for my language, my stuttering today, but if there isn't a way to handle this exception where it occurs, then it goes to a farther method where this is called, where it is handled or not. If it isn't handled, then it keeps going up the ladder of methods where it has been called, and if it is never handled up that chain and it goes all the way to main, then main handles the exception by just terminating the program and printing out to you what the hell happened. So how we would check this, since null pointer exceptions are really easy, we can just do if int array does not equal null. I showed you conditionals and stuff like this in a previous episode. So if int array doesn't equal null, then print it out. It didn't print out anything, since we can do else system.out.println int array equals null. So if we printed this out, oh, I forgot the ending bracket of the else. Okay, so if we print this out, it'll say int array equals null, because it does in fact equal null. So then if we did equals 0, 1, it has two indices, which would happen to be index 0 and index 1. So if we printed it out, it should print out index 0, which is 0. If we had output index 2, which is null, then we should get an array index out of bounds exception, which is another runtime exception. If you try to call for an index in an array that exceeds the array's length, then you'll get an array index out of bounds exception. And again, it shows you the ladder of how it received the exception. So basically, we want to handle exceptions instead of it throwing them. I mean, we could also do or. Actually, no, we can't do that there. But so what we're going to try to do, and try, you'll realize that the pun was intended, is try. Try is another keyword. It's another keyword, and it has to do with catching and handling errors. You'll see there's a error there, but we'll get to that soon. So what we're going to try to do is system.out.println integer array index 3 for now. And you'll see that we'll fit. Now there's two things that can come after a try, and there's one thing that has to come after a try, and that's a catch block. I don't know if it actually, it needs a parameter. So catch, parentheses, you put the exception that you're trying to catch. You can always just do the ubiquitous exception. That means anything that extends exception, which is all exceptions. You could do e.print stack trace, which is what the error did. So you do this, and it should just print out the stack trace. You got an array index out of bounds exception. You tried to access index 3, but there is no index 3, and that's your problem. Another thing you could do is you could put any command in there. You could even put blank, so whenever an error occurs, don't really do anything, which is useless. So, but what we want to do, we can catch exceptions differently. So let's try to catch index array, or was it array index? It was an error. Okay, I unfortunately tried too hard to do anything. And that was an exception. That was an error, you see. It was an error, not an exception. That means the OS, or the OS threw an exception, because we're like, hey, you're giving us this program, but this program doesn't work at all. So here you go. Here's an error. So let's just do that again. It's an array index out of bounds. So exception, and we're just going to do array index out bounds. I just do the acronym for any errors I do, because that's how I do it. Of course, you can do whatever you want. So we can do, we'll just do our own system.error.println. Requested index is out of bounds. That's easy enough. And then what you can do, you can have as many catches as you want. So this time we'll catch a null pointer exception. Null pointer exception. And again, we'll just do a system.error.println and say requested array equals null. And then just in case we get anything else that we don't want, any exception, we'll just do this, and we'll do e.printStackTrace. Okay, so yeah, you can have as many catches as you want. So if we try this, we'll get request index is out of bounds. Now if we, again, did not initialize this, we'll get requested array equals null. And if we get anything else that we don't like, it'll be that. Now another thing you can do is the finally. Oh yeah, fine. Yeah, you can get finally. That means no matter what happens in this try loop, or whatever it catches, or whatever it does, whenever it's done, no matter what, it's going to execute whatever is in this finally loop. So system.out.print line, hey you, we're all done over here. So it'll print out whatever error, and it'll be like, hey you, we're all done over here. I don't care if we got any errors or if we didn't get any errors, but we're done. So we'll just set this to prove that it'll happen invariably. So we'll just go that. It's like it prints it out like we told it to in the try, and it was successful. Didn't catch anything, so it skips over these. Then it goes to the finally, and it does it because we finally wanted it to do that. Okay. So now that we know how to catch exceptions, let's worry about how we can throw them. So we're going to do this. We're just going to say, now if you're going to throw an exception yourself, you have to say that this method throws that exception. So that means in initialization in it throws a null pointer exception. Well, it doesn't mean it will throw it no matter what. That just means it has the possibility to throw it. So if int array equals null, we're going to throw, without an s, a new null pointer exception. So we just created a new null pointer exception. I think we can create it with our own message. So we can say int array equals null. Else if. So basically when you run this, this time we'll set it up with our own integer. We'll just say integer index, and then we'll say public static. Actually, we don't even need to do that. Who cares? We'll just say integer 2. Else if index, if index is less than, is greater than or equal to integer array dot length. So basically, what we're doing is emulating exactly what the normal compiler would do, except we're doing it ourselves. Which, of course, is kind of redundant, but it's good practice. Our own personal message with them. So else system.out.print line integer array index. So what we need to do now is throw null pointer exception or array index out of bounds exception. So now this has the possibility of throwing two things. So we'll just uninitialize this again. And right now, we'll get that. And it shows this, and it shows the requested message we did. But also, now that we know that init has the possibility of throwing errors dependent upon what we do. So now what we want to do is put this in a try block ourselves. Oh yeah, and then we need our catch blocks, and this time we'll just catch an exception, any exception, and we'll just print the stack trace. That's what we'll try to do. So now it has also has our personal message that we wanted it to print out upon the error, and it shows that, and the main method caught it, like it showed here. You try to get this from the main so you called a method from your main method, so it goes to the method you try to call, and where in that method it threw the error. So now if we just initialize this, and now we'll get a different error, an array index out of bounds, index requested was out of bounds, index requested was out of bounds. So what else we can do is just make it so there is no things thrown, and make it sure it actually does what the hell we wanted it to do. So that's how you throw and declare that a method is going to throw it. So now what else we can do is, instead of making a new class and cluttering up my code somewhat, I'm going to do what I showed you in the previous thing and make my own class. Class custom exception extends exception. Yeah, squiggly ones. So we'll say this must have a UID, since exceptions are serializable, which means you could make a certain information saving of exceptions. But we'll get to that, now that I remember it, probably in the next couple episodes, when we also need to get into generic types. But again, yeah, we can make our own exception, so we need a constructor for this exception. So public custom exception, any parameters we want, and it'll do that when it's created. So we'll just create a thing. We'll just create two constructors like any normal thing. One with that and one with a string message. So when this happens, we're going to call this. We'll just call this with no message. And with this, we're just going to do system.error.print line message. So now we created our own exception. So what we can do is just do our own exception. So throw new custom exception. It must be complaining that it's an unhandled exception. So we have to say that since we're not surrounding this with a try catch and it's in this own method, which we could, we have to say, you know, this will throw a custom exception. Just saying. Oh, wait. Okay, now I see, because this is a nested class and such. Let me think. Maybe I had to do... Well, it isn't static. Well, this might actually work. Let's see. No closing instance of type main is accessible. Must qualify the allocation of the closing instance of type main. Okay. Maybe I have to do this dot new. No, that isn't working. Well, yeah, because it's static. Okay. Let's just make a static class. That might fix our qualms. There we go. So now it's static, which makes sense. Let's just throw a new custom exception again. So now, instead of throwing any type of exception, it throws our own exception, which basically our own exception just does what we tell it to do. So if it happens to throw this exception, let's make it throw an exception again. All it will show index was out of bounds. And there was an error at custom exception? Well, no, it must have just automatically print the stack trace. So index requested was out of bounds. So then if we just make this null again, then issue again, integer array equals null. And it comes from our custom exception. So there you go. That's all about exceptions and runtime exceptions. And errors, which you can't, there's no way to control errors or try to catch errors because they automatically just come from the operating system. So if you're running a program with a certain amount of memory, and your program requires more memory than your operating system allocated to it, you'll get an out-of-memory error, which means your system doesn't have enough memory. It'll terminate because it doesn't have enough memory, because it received the error, out-of-memory error, which is impossible to handle within the code. So yeah, that's that. Okay, thank you for joining me on this episode about errors and exceptions and runtime exceptions, and I'll see you next time.